this point, we've compared the different approaches to concurrency between these various languages, but haven't really identified any key differences that really separate one from the other. Sure, Elixir and Erlang does have the added benefits of supervisors, as well as an application abstraction that can help organize these green threads a little more effectively. But overall, they all use a fairly similar approach to handling concurrency with this concept of green threads. And even Node sort of operates as a single green thread that maybe isn't quite as powerful as the other options, but in practice works pretty similarly. In this section, however, I want to go a little bit more into the goals and intentions behind these different languages and how that affects the paradigm of the language, whether that's object-oriented, procedural, functional, dynamic, static typing, runtime or no runtime. All these factors of these languages and characteristics of these languages are part of the initial design, which is based on various goals and intentions for that language. So I'd like to first cover the goals of each of these languages, why they exist in the first place and what their intent is, and how that leads to the various design decisions around that language. Now, the important thing about Node is that the engine, the brain behind it, is the V8 runtime, which is what powers the Chrome web browser. And although V8 is an incredible solution for a web browser, it wasn't built and optimized around building backend systems. And although it does surprisingly well at supporting backend systems, it's not what it was designed to do. And so naturally, there are going to be some limitations and some design decisions that were oriented towards the web browser rather than the backend. And although Node's value proposition back in 2012, when it came onto the scene, was its asynchronous non-blocking I/O, basically its approach to asynchronous programming, it does have a serious issue when it comes to writing asynchronous code. Now, this issue is not at the low-level runtime layer, but instead at the code application layer, where the actual developer is writing code. And this issue really revolves around what I think is the fundamental issue with Node and JavaScript, and that is its open-endedness. There are just so many options between the paradigm, how you handle asynchronous programming, the overwhelming options that are available in the community as far as libraries and packages, and even how you import modules into your project. There's such a wide array of options that it can lead to very inconsistent projects, especially large-scale projects with multiple developers that have different tastes and approaches to building a program. In fact, I was once rejected in an interview process for writing what was considered non-idiomatic JavaScript code, which really made me laugh because there is no idiomatic JavaScript code. I mean, technically, anything that's idiomatic would be prototypal inheritance, but no one really uses that. You do have classes available since ES 2015, but that seems to kind of go against the real design of the language. And then you have the functional approach, which is what I use, but was considered not idiomatic. And in addition, you have various ways of writing asynchronous code, with callbacks being perhaps the most idiomatic because they were the original design choice for handling asynchronous programming. But since then, you've had the introduction of promises, the official standard of promises, and then prior to that, you had Bluebird, which was a library, a promise library that you may find in some legacy applications, but follows the non-standard spec. And you also have this concept of generators, which is a newer approach to asynchronous programming, but is sort of a big departure from callbacks and promises, and probably a lot less common. There's also other libraries in the past that have been used, particularly which is based on coroutines, and that was popular for a bit. But the point is that there's a variety of ways to write code in JavaScript, both from the paradigm perspective as well as from an asynchronous perspective. And I think that's personally a weakness rather than a strength, because it leads to largely inconsistent projects with sometimes incompatible paradigms. With all that said, I will show you a couple examples of the differences between callbacks, promises, and generators, just to give you an idea of how these look compared to each other. So a callback we've already seen. This actually is pretty similar to the event loop example, where basically you provide a function as an argument to a function that is to be executed at a later time by the event loop. Promise is more of a way to chain this sort of behavior and encapsulate it. As you see right here, you can provide multiple promises that can be all executed concurrently and then can be chained for a logic chain that follows what you would see in callbacks, but avoids that whole nested approach where you continue to indent your code each time. So the promises help keep it all at the same indentation level, but are still, in my opinion, a little awkward. And then finally you have generators, which read more like synchronous code, but typically require a layer of abstraction on top of it to really make it useful in practice. So a great example is Redux Saga, which I've used extensively in the past with React applications. And that provides a really good abstraction for using generators in a more synchronous manner. Generators are my preferred way to write JavaScript code, but again, it's probably the least common, especially in legacy applications. So ultimately, the problem with Node is that it was optimized for a web browser and is really open-ended, which from just a productivity and consistency and reliability standpoint, just isn't great for a project. And it doesn't really give you anything truly beneficial to justify these trade-offs, especially when there are other languages that not only handle these things better, but also give you some additional advantages that you're just not going to get with Node. Now, Go has a totally different intent than Node.js. Again, Node really, at its core, was built for the web browser. The V8 engine that runs Node is what powers Google Chrome and is optimized and built around making your web browser work fast and efficiently, not for your backend systems to run effectively and efficiently. Go, on the other hand, solves a different use case. The intent behind Go really is productivity. And we'll see right from the Go documentation that the Go programming language is an open source project to make programmers more productive. Now, this is what I would argue is the biggest issue with Node, is that there's so open-ended, so many different ways to write Node code that it really becomes a hindrance to productivity. Go is the opposite, where you can go from one Go project to another, and it'd be fairly easy to follow how it works, because there's a certain consistency across Go projects that you're just never going to get with Node. If we continue on, it says Go is expressive, concise, clean, and efficient. Its concurrency mechanisms make it easy to write programs that get the most out of multi-core network machines, while its novel type system enables flexible and modular program construction. So really, I believe the intent behind Go was to replace Java in the enterprise. Now, Go's not the flashiest or most impressive or even most performant language, but it is very practical and productive. And when we're talking about enterprise development, that's usually handled by Java. Go is a worthy alternative. It's lighter weight, doesn't rely on the JVM, and has, again, a certain consistency to it that I think has a lot of benefit. For me, Go is a good option for larger companies that are perhaps a bit more conservative, are going to move a little slower, and potentially need to hire large amounts of developers, either right out of school or even in other countries where Java is predominantly taught or used. This is sort of a similar value proposition to Node.js, that you can find JavaScript developers now to write backend code. Well, Go is sort of similar in the sense where now you can kind of easily convert Java developers over to Go and probably be a little bit more productive. And because the Java ecosystem has been so popular, it has some of that inconsistency issues of JavaScript, where there's so many options. Go is so straightforward and idiomatic that there's probably a fair amount of benefit for an enterprise to use that over Java. Now, what Go is not tailored to is concurrency, although it does mention its concurrency mechanisms make it easy to write programs that get the most out of multi-core network machines. It's really not the primary design intent behind Go. And although Go is a really good option for large enterprises that are a little more conservative and traditional, it's probably less suited for a startup that needs to move quickly and also scale reliably should the business succeed and grow exponentially. That's not to say that Go can't scale, because it scales really quite well, but its emphasis isn't as much on concurrency as it is really productivity in the enterprise. And for a startup where you probably aren't going to have that many developers, and your biggest concern is if your business takes off, are you going to be able to handle that load? I think that's where really other languages, I believe Elixir, Erlang, are more suited. So the general rule of thumb for me is I think Go is better for larger companies that are more established, and something like Elixir, Erlang, which we'll get into, is better for startups, and especially where the applications and products need to scale perhaps very quickly. And one other area that I think Go is really a great use case is for systems programming, which doesn't really have the same concurrency requirements as something like a web app or an API. A great example is like Docker or Kubernetes, where really, again, concurrency is not the emphasis, but it's more about lightweight CLI tools that are managing systems rather than APIs that are serving millions of requests every day. So for systems programming, I think Go is a much better option than something like Elixir, Erlang. Otherwise, I think is really suited for the enterprise rather than startups. Now, Rust is a really interesting language. I find it far more innovative and exciting than Go, and I think that's by design. It's not a knock on Go. I think Go is meant to be simple, straightforward, and consistent with the intent of high productivity, and as really a replacement for Java in the enterprise. And for that particular use case, I think it's excellent. But Rust has some more innovative features that that really put it in in sort of its own league. A couple interesting parts of Rust is that it has a very unique way of memory management, where you can write memory-safe applications that are low-level, like C, C++, but without really having to have that experience of writing memory-safe applications. The language itself, and particularly the compiler, basically enforces memory-safe code. And that's really valuable because that does open up the pool of potential developers to a much larger amount. So you don't necessarily need someone who's got a lot of experience writing memory safe applications, which can be hard to find and difficult. Rust sort of enforces that for you, but while also giving you that low level performance of C, C++. And similar to C, C++, it doesn't have a runtime. As you can see right here, Rust is blazingly fast and memory efficient with no runtime or garbage collector. So the reason why Rust can operate without a garbage collector is because of its unique way of managing memory. Basically, there's sort of a life cycle to memory in Rust that eliminates this need for manual memory management. Whereas in Go, you have a runtime that cleans up memory automatically for you, which is nice, but does have an added cost and can create some bottlenecks and performance issues in production systems. In addition, Rust has a very robust type system and really supports polymorphism a lot better than Go. Go has sort of an interesting, somewhat hacky, but also effective way of approaching types. Using the interface type and reflection, you can kind of accomplish polymorphism, but it's not really built into the language like it is with Rust. So I think the main advantages of Rust is that it acts as a memory safe alternative to C, C++, has a much more robust type system, and again, has no runtime, no garbage collection, and no runtime for running asynchronous programming unless you, of course, bring in Tokyo, like we've already discussed. Now, I would say that there are some advantages and disadvantages to this. With Rust being so low level, you can really squeeze out extra performance that you wouldn't be able to get with any of these other languages. But I would say there is somewhat of a productivity cost, because now you are manually managing memory and have to do some of these things that really Go or Node or Erlang will handle for you. So you've got more control, but with that control comes added responsibility, of course. To me, Rust is more of a niche. If you know that you need something that's highly performant, very low level, I think of like hardware drivers, or maybe building databases or anything that you really need that low level control. I think that's where Rust really shines. But for most consumer type applications, or I would say your typical startup, Rust is probably not necessary and maybe overkill at the expense of productivity. However, there are plenty of use cases where Rust really shines, and if your business or project happens to fit one of these profiles, then I really don't think you could go wrong with Rust. What it does excel at is really, really quite impressive, and should always be, I think, on your radar, especially for these specific use cases. And in the case of Erlang and Elixir, sometimes you may want to interop with a low-level language like Rust. So you may basically use Rust for certain modules of your application, whether that's in a microservice architecture or interop with Erlang. But overall, its use case is much more specific, and you'll know when you need it, and it's great that it's there if you do need it. But I wouldn't say it is the default go-to programming language that you should consider before all others. This is largely due to, again, its manual memory management, its lack of asynchronous programming support out of the box, and as well as its powerful but complex type system that is probably going to slow productivity, especially early on and with inexperienced developers. So certainly a tool to keep in the toolbox, but it just lacks the expressiveness and the productivity that I would like to see for a general purpose type of language. So far, we've covered Node, Go, and Rust, and the different use cases that they are appropriate for. As mentioned, Node is really optimized for the web browser, and its biggest weakness is really how open-ended it is, without really any clear, defined standard to follow. Go, on the other hand, is really designed around the enterprise and productivity, especially at larger organizations that may have large amounts of developers and aren't as concerned with moving fast or quick scalability, but more with reliable, productive development. Rust is a little bit more specialized, and when you really need that raw performance and that low level capability that you can't get in a language like JavaScript, which is interpreted and dynamic, or Go, which still has a runtime for garbage collection and asynchronous programming. Rust really gives you that extra little bit if you need it. And Rust also has the most sophisticated type system out of these languages, which can be good, but also can be a hindrance to productivity, especially with inexperienced developers. Now, with Erlang and Elixir, the goal is a little bit different than the other languages because really the emphasis of the language is around concurrency. It was originally designed for telecom to handle all the phone calls going through these networks and ensuring that they are delivered reliably and that these systems are scalable and fault tolerant, which has become more and more relevant as our applications have scaled over the last 10, 15 years, even though Erlang was originally designed in the mid-'80s. And this explains why Elixir exists, because it was created sort of as a way to reintroduce Erlang, but in a modern fashion. Now, what's interesting about Erlang and Elixir is really the whole language is designed around supporting concurrency. Whereas the other languages have other goals, again, web browser, enterprise, and low-level performance, Erlang and Elixir is made for concurrency. And that's why I think it's the most general purpose of these languages, because most startups and projects today, although not all, there's plenty of exceptions to this, but I think for any web applications or APIs, concurrency really is the name of the game. Now, this goal of supporting highly concurrent, fault-tolerant applications led to some design decisions around the paradigm as well as the type system of Erlang and Elixir. So basically, rather than starting with these things and then working concurrency into this language, Erlang and Elixir really started with, hey, let's solve for concurrency, and then based on what we decide is the best approach there, we can design the rest of the system, being the language, the VM, the type system. Let's design all that around the most optimal approach to concurrency. This has led Erlang and Elixir to follow a functional paradigm, unlike the other languages here, which are either mixed or more procedural, and has also led to a dynamic type system, whereas Go and Rust have a static type system. So Elixir Erlang is more similar to Node in the sense that you can annotate types and create types that can be statically analyzed, but the language itself doesn't have a type system. And there's advantages and disadvantages to that, but in the case of Erlang and Elixir, this is an advantage because with the functional paradigm, you're not really using any shared objects like you do in an object-oriented language. Everything is being passed as arguments. So there's never any shared memory, which is actually why it handles concurrency so well. In fact, with a functional approach in avoiding the shared memory limitations of object-oriented programming, operations can scale across machines in Erlang and Elixir, and in fact has built-in networking mechanisms to enable this. So you can actually distribute load of processing across multiple machines fairly easily and effectively in Erlang and Elixir, that may require more thought and consideration in other languages. Now, there are some trade-offs to this. First off, functional programming tends to be a little less common. It's not really taught as much in school. The more typical object-oriented classical inheritance Java style programming tends to be how most people learn programming. And so it can seem like a big departure from what's familiar. Although more recently, really since React has come onto the scene, functional programming has made big resurgence, particularly in front-end development, as React and Redux has become really the standard, and even other projects like Elm have really demonstrated the benefits of functional programming, especially for UI development. And that is why I think Elixir and Erlang do make for a fairly easy transition for front-end developers or full-stack engineers that have worked with React and Redux and maybe come from the Node world. I think they're going to find this functional approach to be pretty familiar and similar to what they've been using if they've been using Redux. In fact, Gen servers, which you'll see right here, an example of, really does follow a very similar pattern to a Redux reducer, in the sense that it accepts various, what you could call actions. So you'll see right here, this lookup action, and then you have an argument. So basically, this would be like the action in Redux, and then the data that comes with it, and then the existing state. So in this case, we have names. So what a Gen server really does is it acts as like a Redux reducer and is how you store state in a functional manner in a backend system. And this Gen server pattern here is time tested and really is so common of a pattern in Erlang that it's really an official part of the Open Telecom platform, OTP, which is really a group of different technologies and patterns that are used in the Erlang community. And so anyone who's interested in functional programming or has been working with functional programming is going to find, I think, Elixir to be a very comfortable and pleasant language to work with. But if you're coming from a more traditional object-oriented inheritance style language, it may seem pretty foreign and unusual at first. Now, the other main thing to keep in mind about Elixir Erlang is its runtime, which is known as the beam. Now, just like Node has the V8 runtime, which again acts as sort of the engine behind Node.js, and Java has the JVM, which really was built for portability back in late 90s. The beam is built and optimized around concurrency. Although this introduces a lot of benefits to the project, it also can introduce a fair amount of overhead, which makes it not as suitable for some types of projects. Again, I think of like CLIs and systems programming and stuff that I think Go is more suited. But for concurrent applications, you'd be hard-pressed to find a runtime that is more suited for that use case. Again, Beam, the Erlang VM, is designed for concurrency. JVM, portability. V8 is really designed for the web browser. So if you're building a backend system, what really is your priority? It's probably concurrency, especially if it's an API or a web server. So it just seems natural that you'd pick the tool that is optimized and designed around that use case rather than a use case that might not be as relevant. And finally, there's another interesting aspect to the Erlang VM. Because the Erlang VM runs bytecode, which is not quite a binary, but it's not interpreted code like you have with JavaScript. It's somewhere in between. The way I like to describe it is like a interpreter binary code. So it's somewhere in between binary and interpreted code. What's interesting is that you can actually hot swap this bytecode on a running server without actually having to stop and restart the server. This is again because Erlang was designed for telecom. Downtime is not acceptable. You can't just have the phone systems down for 10 minutes to redeploy code. So they actually engineered a really sophisticated solution for swapping out code while a server is running, which is pretty incredible, but in practice today isn't entirely useful because the ways we deploy applications with like Kubernetes and containers and all of that, where it just doesn't work with that paradigm. But it goes to show the level of sophistication that the Beam has, and really is something that you don't get elsewhere. And finally, I think what's most interesting about the Beam is due to its approach to applications and processes and supervisors, it really challenges the whole microservice approach that's used today, because you sort of get the process isolation and a lot of the benefits of microservices sort of out of the box with Erlang. In fact, I've heard it described sometimes as nanoservices, where really a single deployment is made up of these isolated microservices that are considered applications inside of Erlang, and combined with supervisors, automatically can restart these services if there's issues, which is, let's face it, ultimately how we solve most problem with our microservices today. We just restart the service. So Erlang will actually sort of manage that process for you automatically and maintain that isolation, so you don't have to worry about crashing the other processes in your app. You have just a single deployment that acts as sort of virtual microservices. Now, this doesn't address the common problem of monolithic applications. So you still need at the development level proper code separation and application boundaries. But from an actual execution standpoint, Erlang does work effectively as a group of nanoservices that really does challenge the microservice approach that we use today. However, you can still use Elixir like you would any other application microservice architecture. It just has this extra layer of its own microservice architecture, if you will, combined with the ability to swap out live running code. So it kind of gives you everything you would get within a modern language, but then a couple other extra features that are there should it be appropriate for your business or project. In conclusion, this section was really about exploring the different use cases and reasons that these languages were built. As always, you want to use the best tool for the job. And considering how unique and diverse software projects can be, there is no one-size-fits-all. However, I do think there are clear reasons to use certain languages in certain circumstances over others. In the case of these 4 languages here, Node, Go, Rust, and Elixir, I believe that Rust is appropriate for when you need the absolute most performance and low-level control. Go when you perhaps are a larger, mature company with hundreds or thousands of engineers and aren't as concerned about quickly scaling or quick productivity, but more maintaining the status quo. And perhaps you want to tap into the large base of Java developers or even recent CS graduates that are available, and perhaps even building offshore teams where Java will be pretty commonly known. However, if you are a startup and mostly concerned with moving quickly, staying productive, and want to ensure that if you reach the success that you're looking for very quickly, that you can handle that and scale accordingly and reliably. Because the last thing you want to do is put all this work and then finally reach that moment only for your software not to be able to support it. So I personally believe for startups, unless you need that low-level performance of Rust, or you're perhaps based in like some systems programming like with Go, I really think Elixir should be the go-to language because it really is the most suited for web servers, APIs, and concurrent applications. As far as Node goes, I believe that that is the technology that people are most likely to choose before Elixir in startups. This is mostly due to the pool of developers familiar with JavaScript rather than the merits of Node.js for backend systems. And this is why I believe that there are no reasons to select Node over Elixir in 2021. There are no technical merits or advantages that Node provides over Elixir. The only real advantage comes in hiring and familiarity with JavaScript. And I think the thing that really needs to be kept in the front of mind when considering Node for a project is that even though it may be easy to get started with Node, it's extremely difficult to scale Node because of its inconsistencies, mixed paradigm, different choices for asynchronous programming, and overall its limitation being built for a web browser. And though it may seem that you can get things out a little bit quicker with Node and hire a little easier with Node, the benefits are short-lived, and over the long term, Elixir will greatly outperform both from a performance perspective and from a code management and productivity perspective. And in the next section, I'm going to go into some really unique, exciting, or innovative features that Elixir provides that you can't get in Node or these other languages that really help separate it from the rest of the pack